Hi, today we'll see the mold wash from manufacturing technology. After the pattern withdrawn purely carbonaceous materials such as sea, coal, and finely powdered graphite, and the prosperity of the compounds are applied to the mold cavity. This is called mold wash, and it's done by spraying, swabbing, or painting in the form of the wet paste. There are used essentially the following reasons: to avoid the molting metal interactions and prevent sand fusions, to prevent metal penetrations into the sand grains and thus ensure the good casting finish, to deposit the mold wash either water or alcohol can be used carrier, but because of the problem of getting the water of mold, alcohol is preferred as a carrier. The prosperity of the washes available in the powder, paste, and liquid form. The powder needs to first and prepared and applied, whereas the sand slingers in these machines, the sand is thrown to centrifugal force from rapidly rotating a single bladed impeller and directed over the pattern flask. The molding sand should not be mixed with suitable binders, etc., so that it can be flow into the place readily, and afterwards binder should become hard. In this method, the sand density is more uniform and at all levels, and it is therefore best suited for any type of the molds. However, it is best adapted to work ranging from medium to large size. The density it can be controlled by changing the impeller speed. Advantage is the process is very fast, remaining is very uniform. Initial cost of the equipment is high comparatively. The casting defects of hot tions, the temperature gradients establishing the different rates of contraction during the solidifications, and thereby including the stresses due to the resistance of the sand and a magnitude of sufficient to cause the fractures. These can be minimized by adopting a good design. Then the CO2 molding process is a sand molding process in which the sodium silicate and water glass is used as a binder 2 to 6% rather than the clay. After the mold is prepared, the CO2 gas is needed to flow through the mold and the sand mixture the hardness through the very rapid reactions about the 1 minute, which is very less than the several hours needed to produce the dry sand yielding stiff gel. Then CO2 molds can be used for producing the very smooth and the intricate castings because the sand mix has very high flowability to fill up the corners and intricate the contours. Advantages: the CO2 molds can be made without the flask. Sands are free flowing, therefore ramming is eliminated or reduced. The tensile strength of molds are higher than those conventional molds. This permits the introductions of mold weight and easier handling of large molds. Disadvantages: sand must be used immediately. The composite molds are made of two or more different materials such as sills and plaster, sand with binders and graphite. These molds are combined the advantages of each materials. These molds are used for the shell molding and other casting process, generally for casting the complex shapes and such as turbine impellers. Advantages: increased mold strength, improved the dimensional accuracy and surface finish of the castings, reduce the overall cost of the processing times. What is a dry sand molding? Invariably, the sand mold is dried after the pattern is in order to increase the strength of the molding so it can be withstand the high static pressure and liquid case of the big castings. Sometimes clay bonded dried mold castings are used to obtain the greater dimensional tolerances, obtain the better surface finish. CO2 process of making the stove coarse and is briefly. Clean and dry sand is mixed with solutions of sodium silicate and rammed or sewn in the core box. The mixture is then gassed with a CO2 gas of several seconds of CO2 forms a silica gel which binds the sand grains into the strong solid form. If required, the additional hardening sodium silicate and the mixture of gel cannot be reclaimed after the use. The various molding defects are sand spots and internal air pockets, sand holes and blowholes, honeycombing, springes, oversizes of castings and swelling, mismatched lifts and shifts. Poor ductility and porous in nature, lower density and poor strength, less stronger than the drawn products and poor finish and less costly. Castings applying the molding process have a good hardness. The sand casting is susceptible to cooling. The cracks in if proper care in design is not taken. Suitability of sand castings lies with high melting and molten metal. The molding method is suitable for moderate and particularly large castings and unsuitable for the thinner sections. The sand castings can be made internally sound by minimizing the gas evaluation during the solidification by avoiding the turbulence by pouring. The core dressing: it is the operations applying the compound to the surface of the core, either in the green gate of the backing or purpose of providing the protection against the sourcing action of following molten metal and assist the formation of a smooth surface in a core and core form. Core chaplet: the core chaplet is a metal locations twice inserted in a mold, either to prevent core and shifting its position or give extra support to a core. The molten metal melt the chaplets and which then forms the part of the cast material. There are some important design rules of considered in sand castings to ensure the minimum disposal of stress and minimum stress concentrations is water வந்திருக்கான் can concentration in order to increase the reliance of ductile metals of fatigue. Rupture's external corners should be rounded with radii 10 to 20% of the section thickness, and the complex of the sections like X, Y, V and K should be staggered and staggered T. In joining sections, dissimilar size of L or T sections at the equal thickness of small section should be provided. In the case of L junctions, largest possible radius should be used. The load bearing capability with complex loads is increased by adopting the tubular or reinforced C sections rather than the I and H or the channel sections. All the metal dirt is used while pouring does not the end of the castings. There are some losses in metal, then there is a possibility that some castings may be rejected because of the presence of various defects. On completion of casting process, the gating system is used to remove the solidified casting and remelted to be used again as raw material. In the casting yield is the proportions of actual casting mass. Casting yields depends upon a great extent casting materials and complexity of slope. Generally, those materials of strength heavily have a lower casting yields. Also, massive and simple shapes have higher casting yield compared to small and complex pots. Higher casting yield higher is the economics of foundry practice. It is therefore desirable to give the casting consideration and small and complex pots. Higher casting yield higher is economics of the foundry practice. It is therefore desirable to give the consideration of maximizing the cast yield at the design stage itself. In order to facilitate the removal of curtain from the molds, separate solidified casting from the permanent molds. Tappers must be incorporated in all sections. The tapper also induces the directional solidification. As far as possible, all the corners should be rounded and re-entrant of the sections must be wider. Free liquid metal in order to allow for the shrinkage of metal from freezing point at the room temperature. Pattern markers of shrinkages allowance and should be provided for forming the cavities and re-entrant of the sections. Cores must be used. Number of complexity of the cores melted should be minimized. The gases of the castings may be appear the gas holes and pinholes. These defects can be avoided by the proper riser design and adequate venting and permeable molds. Another source of the gases is form of the dissolved gases in the liquid metal. High temperatures which on the cooling off the gases melts, the water can be reduced by vacuum melting. The vacuum degassings in low pressure chamber and remove all gases. In the case of the non-uniform cross section, the casting of different sections is solidified at different rates depending upon the cross-sectional areas. This results in varying amount of contractions in different parts, producing the high internal stresses which may cause tearing and cracking castings. High residual and internal stresses can be avoided for the placing the chills over the large cross-sectional areas so that the whole casting tools are uniform rate. Such stresses can be also controlled by taking out by casting at an average temperature of 750 degrees centigrade and can, can uh, uh, putting into the uniform rate. The following points are worth mentioning. Any temperature gradient above the 540 degrees centigrade and give the raise of the elastic strain because of the same is relaxed. The plastic rate of the I rate of the creep. In the case of the I residual stresses exist in casting, it has to relieved by suitable treatment by and the other methods of stress relieving. Chill casting process is nearly similar to the sand casting. Is used for the very hard outer surfaces and wet resistance castings are required. Molds or mold stands of the casting purpose of chilling cast iron steels blocks are used. Metallic chills are used on the outer surfaces so that the rate of the cooling increases and ends as in the case of the railway bridge show. Excess chilling effect reduces the preheating modes. In the case of the bushes and bearings, the inner surface of the hole should be hard and wear resistance and to meet the requirement of the core chills are used in the molds. Extensive chills are used to reduce the possibilities of defect is called on tear. Cooling rate has considerable effect upon the hardness of the surface. The greater rate cooling is lesser amount of the carbon will come out in graphite state. In the other words, the carbon will combined form ends the casting will be hard. The wheel tread and tram car wheels, chill rolls also, rolling mills of the machine toolways and railway brake shoe and crusher job. The melting pot is graphite. It should be fired by gas, oil, rug and cost is more than the cupola and quality iron is better. The induction furnaces, it is easier to melt and obtain the different grades of iron. It is the cost high, recommend also more. The arc furnaces are good melting steel. The additives can be easily added. Open air furnace, the grade of the iron produced is good. It is the furnace of all gases or circulator. The lining of needs renewed every year. Cupola, it is the material cost is low. It is the high production units. The quantity of the melt is average. Water jacket is necessary for melting. The fluidity is normal foundry. Designate the casting materials. Ability to fill the mold cavity. Fluidity depends upon the casting materials as well as the mold casting materials. The properties of affects the fluidity. Great extents are viscosity of melt, heat content of melt, surface tension, free range and the specific weight of the liquid metal, mold properties of the fluidity, thermal characteristics, permeability, mold cavity services and the most of the commonly aerial fluidity test. The mechanist foundries of the when the machine molding is employed, the system sand is used to fill the whole flask. Since the whole mold is upon the system of sand, the strength of the permeability refractiveness must be together with the backing sand. Whereas the facing sand is always to make the dry sand molds on the system sand frequently the green sand molding. The crystal may be visualized from the center of the nucleus, which is composed of small groups atoms. Common crystal patterns, nucleus being the potential crystal and able to grow to form the crystal large enough to underrated eyes each of the leaches of growing crystal and atoms it or similarity of oriented. No nucleus within the freezing melts may be formed which is planes in groups, same as do any other nucleus. Thus, when the individual crystals have grown to point absorbs all the liquid comes in contact with the boundaries, they do on line up their planes of atoms, change the directions ongoing from one crystals of different orientations, and we have the crystal of aggregate and mixed crystal of each crystal therefore composed of group of similarly oriented atoms, but on going from one crystals to the neighboring crystals orientation changes. So far the nature of the crystal border is still not known only, but may be assumed that it is an interlocking border line where the atoms of one crystal change the orientation from the atoms of another crystal. It may be that there are some left over not knowing to which the crystal to attach themselves, and these act as a non-crystalline cement between the various crystals. These conditions may account for greater strength of the crystal boundaries or compared to the strength of the individual crystals, and for many actions that takes place the crystal boundaries. The crystals which form the process of solidifications may have many different structures depending upon the rate of the cooling and the type of the admixtures of impurities in melt. The effect of the crystals of proper external shapes can be obtained only crystallization develops under the conditions when the degree of supercooling is very slight and the metal has very high impurities. The crystal nucleus form and proceed over sorts of solidifications, forming the skeleton crystal. In much same way, the frost curtains form. Atoms attach themselves to the axis of green crystals, form the metal progressive layers finally the filling the axis and then completed the crystals. The free energy from the solidification of the process, it depends upon the volume of particles formed and replacement of the old phase and new phase accompanies of decrease degree of freedoms and new phase. The segregations, the separating out of the constant element with different freezing temperatures when a lead along the metal cools and solidifies. Normal segregation of solidifications moves away from the walls as the plane front. The constants having the lower freezing point are driven towards the center of the resultant of castings. The gravity segregations, the strength of the segregations takes place due to the gravity. The elements have high density of the zinc and the bottom mold should have the higher elements will float on the surface. This results in the castings richer and the higher density of the elements at lower part and upper part will be the richer and higher elements. The micro segmentations, the core dendrites of having the higher concentrations allowing elements at the surface of core dendrite. This is due to the solute of the rejections of core towards the surface during the solidifications of dendrite. This is known as the micro segregations. An alloy consists of elements which freeze different temperatures when the liquid is poured into the mold. Higher freezing points of the metal will be formed with the first crystal of metals having the lower freezing point will start nucleating. In casting mold, the cooling and solidifications start from the molds and walls and progress inwards and towards the center of mold. The course of the consequently the outer surface of the casting is richer in higher freezing point of elements. Owing to this, casting will be non-homogeneous properties. It will contain the different compositions from the crust core. Moisture contents affects the various properties of mold. Under it increase the permeability of the first, then it starts decreasing permeability. When the water content is more, it increases the compressive strength of the faster rate. Subsequently, at slower rate, it decreases the grain strength. Die castings are made by forcing the molten metal at high pressure into the split steel die cast cavity. Within the fractions second, the fluid alloy fill the entire die. The die water cooled, therefore the low temperature is being maintained. Because of the low temperature of the die, the casting solidifies quickly. Rises serves as a feeder. A field mold metal casting cavity is to compensate the shrinkage toward the riser. Also helps to in easy ejections of steam gas of the air. Mold cavity while filling the molten metal. The risers act as a reservoir, heat gradient regulator, and provide the necessary fluid metal compensate the solidifications. In the case of the risers is provided during the casting solidification will start from the ball's liquid metal. The center will be surrounded by solidified shell. Contracting the liquid will produce the voids toward the center of casting. Normally, the gases exist the molecular form of the high temperatures and contract with the metal of significant portions of gases may dissociate the atomic form of in either into the metal, and these gases can be accommodated in the relatively loose and disordered structures of metal. This causes the high solubility of gases. Above melting point, the solubility of the gases falls sleepy as the melt solidifies. Some gas may be trapped in solid in atomic form, but much is rejected at the solid liquid interface to combine into the molecules. These molecules come together and form the groups into gas bubbles, which rise in the melt or, if trapped during the solidification, cause gas porosity in structures. These gas pores are generally round, and if they contain the neutral or reducing the gas, they have a clear bright surface. They too can regarded as inclusions of zero strength, but the large radius makes them less damaging to mechanical properties. The blue holes also cause the blistering. All the gases in all the metals are not equally soluble. The hydrogen is soluble in practically all the metals because of small size of its atoms. The hydrogen may be introduced into the melt of dissociation water from the air. The charge of combinations of the products, the contrast of hydrogen, nitrogen, insoluble iron, but not in ferrous metals, noble gases. The centrifugal casting process is carried out the permanent mold, which is rotated during the solidification of castings. For producing the hollow part, the axis of rotation is placed at the center of the desired casting. The speed rotation produces the centripetal acceleration, which segregates the less dense non-metallic inclusions near the central rotations. The solid parts can be made by variations of this process by placing the entire mold cavity and on the outsides of the axis of rotations. The castings produced by this method, parts of the cylinder liners extra. The true centrifugal castings, semi-centrifugal castings, and centrifugal castings. The true centrifugal castings is against the wall of the mold, the centrifugal force, and no core is required to form the cylindrical cavity on inside. The cast by rotating the mold about the horizontal or on the vertical axis. The castings are much smaller than the weight because of stability to spinning the vertical cylinder. Semi-centrifugal castings. In this casting, the mold is completely free metal as it is spun about its vertical axis, and riser and courses may be employed. The center of the casting is usually solid, but because of the pressure is less, the structure is not dense inclusion and entrapped the air often present. The rotational speed for this form of the centrifugal castings are not great as true centrifugal process. In this method, normally used for pots in which the center castings will be removed by machining, the centrifugal castings. In this case, the several castings cavities are located around the outer portion of the mold, and metal is fed to these cavities by trail gates from the center. Either the single or the mold cavities are filled under the pressure from the centrifugal force of the metal as the mold rotated. Need for the investment casting. The investment casting is used for the intersheet shapes, good dimension accuracies, and very good surface finish are required. The investment casting is suitable for high melting point alloys as well as the difficult missions of metal. It is also suitable for processing the small size castings having the intricate shapes. Investment castings process the preparation of each disposable pattern together with gating systems is done. The injections of bags thermoplastics and into the die cavity. The tree is prepared for the number of such pattern is fixed of a wax plastic and runner with suitable ceramic cap to act as a pouring basin. The tree is dipped into the ceramic slurry and sufficient fine silica sand is sprinkled on the tree dipped in the ceramic slurry. This enables the formation of self-supporting and ceramic shell mold formed around the wax assembly. The ceramic shell mold is then backed so that the wax melts flow having the mold cavity. The shell fire between the 850 to 1000 degrees centigrade to eliminate all the wax, give more strength to the mold. The molten metal is poured into the mold while it is still hot and cluster casting is applied. These days of the lost wax process used for manufacturing the larger objects like cylinder, woods and crank shafts and process. The glass casting is generally involve the process of low temperature melting alloys. In this process, hollow casting can be produced without the use of the cores. The principles involves pouring the molten metal and permanent mold. After the skin of the frozen, the mold is turned upside down and slung to remove the metal still liquid. The thin-walled casting results. The thickness depending upon the chilling effect from the mold and the time operations. Toys ornaments are made by this process for zinc head tin alloys. Electroslag casting. This process is unusual in that it does not employ the furnace. Instead of consumable electrode melting, striking beneath of a slag layer finish molten metal to fill the water cooled permanent mold. The precision casting, it employs the techniques that enable the very smooth, highly accurate castings to be made from the both ferrous and non-ferrous alloys. Pressed casting. This method of casting resembles gravity of the slash of processes but differ somewhat procedures. This is also called the Corteos castings. The product designer who select the castings primary manufacturing process should make the design does not only to serve the functions being capable of withstanding the loads and environmental conditions to which going to subjected due to the service life, but also fabricate the favor of casting process, promote directional solidifications. When designing the mold, rises should be properly dimensioned and located to promote the solidification of casting toward the risers. In other words, the presence of large sections, heat masses, and in locations distance from the risers should be avoided for good reason. Presence large sections and heat masses in location distance from the races should be avoided and good racing practice should be followed. The failure to do so many results of shrinkages, cavities, and porosities or cracks in those large sections distance from the races, avoid shortening and columnar solidifications, dendrites, and often the form of the cold surface moved and grow to form the columnar casting structures. This is almost always results in planes, the weakness and sharp corners. Therefore, rounding the edge of the necessary dominate the development of planes in weakness. Avoid on the spots that rate of the solidifications and heat dissipations to sorts with the lower locations have low ratio of the surface area of volume. Such locations are usually referred to as hot spots of the foundry practice. Unless the precautions taken during the design phase, the shrinkages cavities can be avoided modifying the design. Also, it is always advisable to avoid the abrupt changes in sections, avoid the cause of the arteries in the casting defense, tensile stresses, and retaining the casting efforts should be made on the causes of tears. The ensure the easy patterns to withdraw. It is important the pattern can be easily withdrawn from the mold. Undercuts and protruding bosses and axes do not fall within the and light should be avoided. The continuous process pouring the molten metal into the molds and facilities for rapidly the metal joint of solidifications. It has been proved through the research of experimental work. There are the many opportunities for the cost economics in the continuous castings, having the degree of soundness and uniformity not processed by the other methods of producing the bars and billets, smoother surfaces, freedom from the gas porosity, freedom from sand and dirt, rapid rate productions, low cost and skilled labor needed, clear tolerance, free from the internal strings, high percentages of the good castings. Composite molds. These molds are made up of two or more different materials. Shell molding and other casting process. Commonly used molding metals include the shells, plaster, sand with binder metal, and graphite. These molds may also include the cores and seals, control the rate of solidification in critical area of castings. The composite mold have increased strength, improves the dimensional accuracy, surface finish of castings, and may help reduce overall cost of processing time. Rammed graphite molding. The rammed graphite instead of sand is used to make the molds. Castings. Reactive metals such as titanium, zirconium, sand cannot be used because these materials react vigorously with silica. In this method, packed rather like anhydride 175 to 870 degrees centigrade, added support normally required with a large cope flask to keep the molding sand. For sagging, folding, the cope is raised to remove the pattern. The balls are subdivided into the large cope box flask areas. The smaller areas which are available supports themselves should be extended downward within the 20 to 50 mm when the added supports are needed. Gaggers should also use. The gaggers are L-shaped steel rod. The gaggers extend vertically downwards from the top of the bar within 25 to 50 mm pattern and surface. The gaggers are generally dipped in clay slurry to improve the bonding of mold and sand gagger. The other surfaces should be rough to help them to find the grip in the sand. The fractionless mold process employs the principles of when properly bounded, the high strength of mold. The sands not less than the 185 gigapascals and the ramming pressure or high strength enough to 15 megapascals. Integrity of mold. The molding process of vertically potted the flaskless molding machines to pattern plates. One fastened pressure plate and machine and the other is counter pressing pressure plate. The pressure plate and initially the sand is shown from the blower and into the molding chamber and actions of compressed air. The entrance of the chopped off the ski plunger moves forward and compacts sand into the 8 to 15 megapascals. The pressure plate of the machine moves always in turns inside. The plunger then pushes and the sand block, thereby forming the mold cavity. In this manner, the continuous row of mold produced advantages. The casting produces high quality of manual labor is fully excluded. The casting flasks are not required. The process are very effective of mass productions. High strength of the mold. Minimize the ball movement during the castings. Applications. Malleable iron pipe fittings and brass valve bodies, gas stove grills, etc. The recent castings process variant conventional continuous casting methods. The molten metal contains the solidified and the electromagnetic field instead of conventional mold. There is no sliding contact of the molten metal with the mold walls and the metal can be solidified by direct water impingement. The surface finish of the casting is very good process, can be automated. The method is being used obtaining the continuous stands of metals. The list of factors influences the noise of the proper castings method. The following factors influences the volume casting requires, weight, complexity of the shapes, types of goods needed, cost of the pattern or die, and working characteristics, surface quality required, cold welding, hot welding, liquid metal welding, metal spraying, and noting of imperfections. The The metal velocity of faulty designed by the pressure may be below the atmospheric and gases of organisms. Baking of organic compound may be altered molten metal steam, producing the porous castings. Screw designs. The pressure at points 1 and 3 atmospheric and it is negative. Darted problems may be overcome by making the screw tapered. The sudden change of flow directions. In this case, due to the change in direction of flow metal, vena contracta is experienced. The negative pressure in the region can be avoided by making the mold shapes per profile of vena contracta. The shovel consists of square prisms, square pan fitted the wooden handle, radial. It consists of the wooden frame, screen, and the bottom is reduced. The hand riding and the sand remove foreign materials from it. Reamers is a tool used from the foundry workers and consolidating the sand, and uses of the sand is rounded evenly. Swelling may occur. The metal neighborhood of many soft spots so that the resulting casting will not be true. The strike of bore. The flat bore of the strike of bore. Excess sand is to be removed. Vent wire. Ramming. After ramming, the excess the vent is used to make the holes. Slick is used to variety of the shapes. Slick is reporting to finishing the mold. Lifter. The lifter is the section of the steel lengths of the right angles, and the lifter are used to removing the loose sand from the inside the mold cavity. Swab. The brush of having the long M fires. The swab is used. Bellow. The house of the unwanted cavity in the mold is to be removed. Travels. The superfinishing of the joints of the molds provided the molten handle. Gator. Gator is U-upstated. Draw screws. In the wrapping pail, the miles wheel of the rods carrying the loop ring wood, the machine screw with they are always used in conjunction with wrapping plate for wrapping, withdrawing the pattern from the sand. The wrapping plate is provided for the several hole accommodate either the wood screw driver or type or main machine screw driver type. Screw pin. Embedded the mold of the later withdrawn produce the holes is called runner. Mallet. There is a similar wooden mallet carpentry. In foundry, mallet draw spike of the pattern of wrapping it. The gaggers. These are the bent pieces of the wire reinforcing and downward for projecting the mass in the cope. Clamps. They are molding the firmly together during pouring. Casting perhaps oldest method of manufacturing, invariably first step sequence of manufacturing product. The basic feature of common bearing casting process are pattern and mold, melting and pouring, solidification and cooling, removal, cleaning, finishing, and inspection. A pattern defined as the model castings constructed in such a way that it can be used for forming an impression in damp sand. The following allowances are usually provided in a pattern: sinkage allowances, draft allowances, taper allowances, machine allowances, wrapping allowances, distortion allowances. Mold may be defined as the negative print of the part of the cast obtained by the pattern. The molding sand container into which the molten metal is poured and allowed to solidify. The sand molding methods may be classified: the green sand molding, dry sand molding, skin dried molds, loam sand, metal mold. The core specially designed shape of employed to take the place the metal in the mold. Casting means pouring the metal mold of the solidification occurs. Sand castings, shell molding, permanent mold casting, die casting, centrifugal casting, investment casting, plaster casting, slush casting, continuous castings. Then, casting is perhaps oldest methods of manufacturing. First steps sequence of manufacturing product. A pattern is defined as the model of castings constructed in such a way that it can be forming an impression of mold damp sand. A pattern consists of two pieces is called split pattern. Matchlet patterns are suited for the mass productions or small castings of molding machines. Segmental patterns are generally applied for the circular work like rings, wheels, rims, gears, etc. The construction of metals alloys always volumetric and linear, but construction allowances measure in linear measures. Machining allowances is extra material provided for the certain details of casting so that the casting may be machined exact dimensions. Wrapping allowances is provided for compensate the enlargement of mold cavity because the excessive of wrapping for manufacturing the machine molding is suitable. Molding is carried out in molding boxes is called flask. Sand molding is example of permanent mold. Bench molding is used for large castings. In pit molding, the pits acts as a track. Metal molds are used casting of low melting temperature alloys. A core is specially designed shape employed to take the place metal in the mold. Core box is a type of box used for production sand cores. Stickles are for features used with core boxes to obtain the shapes of large works. An open earth furnace chiefly productions of refining purposes. Casting means pouring the metal in the mold where the solidification occurs. Permanent mold casting, the casting process in which steel molds and cores are employed. Investment casting is press, also known as the last wax precision castings. A cold shed is an interface with the cast formed when two metal streams meet without complete fusions. A mismatch is shift individual parts casting with respect to each other. Scad is shallow and blow. Hard tears are cracks having the ragged edges of tensile stresses during the solidifications. Scab defect affects when the portions of the face of mold lips breaks down on recesses thus made filled by the metal. Rough cleaning casting does not include the removal of gate or risers. The term of the castings are preferred, the methods of manufacturing, the various casting process or the patterns materials, patterns depends. Thank you. We'll see you next video.